Identify the substance and its chemical bonding. Potassium fluoride, Kf, is composed of potassium, K, an alkali metal, and fluorine, F, a halogen. Because it consists of a metal bonded to a highly electronegative nonmetal, Kf is an ionic compound made of K to the power plus cations and F to the power negative anions. Recall the physical structure of ionic solids. In the solid state, ionic compounds do not form individual, isolated molecules. Instead, they assemble into a highly ordered, three-dimensional crystalline lattice. Apply the principles of electrostatic forces. Coulomb's law: the stability of an ionic lattice is governed by Coulombic attractions and repulsions. Attractive forces occur between oppositely charged ions, K to the power plus and F to the power negative. Repulsive forces occur between like-charged ions, K to the power plus with K to the power plus, and F to the power negative with F to the power negative. To maximize attractive forces and minimize repulsive forces, an ionic solid must pack its ions so that each ion is directly surrounded by ions of the opposite charge. This structural arrangement represents the lowest potential energy state attainable by the constituent ions. Identify the diagram that matches this stable configuration. Option B represents a tightly packed, highly ordered crystalline structure where every positive cation is directly surrounded by negative anions, and vice versa. This correctly depicts the stable lattice of solid Kf, making option B the correct answer. The correct answer is option B, structure showing tightly packed ions surrounded by ions of the opposite charge.